Well, good afternoon, good morning, good evening, good night to wherever everyone may be somewhere in our lovely planet. Thanks so much for joining us live here today for the one and only, the cool Serverless Office Hours, streaming live on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. So wherever you are joining us from, you are more than welcome. Thanks for joining us. My name's Julian Wood. I'm a developer advocate here at AWS, and joined by two returning guests, utter experts in the world of serverless. Ran, a principal architect at CyberArk and an AWS serverless hero. Ran, you know more about serverless probably than many people on this entire planet. So tell us your journey to serverless and what brings you to us today.
Oh, wow. That's a long one, so maybe we'll keep that for later. But
it can be brief.
Yeah, we built a platform engineering. We started a platform engineering group at CyberArk, and basically we led the way to serverless adoption across the organization. We have over 1,000 developers. So I'm here to share our insights, knowledge, why we did platform engineering, that sort of stuff, basically.
Excellent. And Anton, you're within the wheelhouse within AWS. So yeah, you're a principal solutions architect. Tell us your sort of day-to-day workings with serverless.
Well, after something like 20 years of building application, like cloud applications as well for the last 10 years, right? I've discovered serverless about a little over 3 years ago, right? And I fell in love, right? So when you can actually focus on building applications and not managing, all the stack under your application, not because you want to, but because you have to, right? That was my kind of love story with serverless. So I'm a solutions architect here at AWS. I primarily cover large customers, what we call ASV, independent software vendors, right? And a big part of my day-to-day work is not just understanding how you efficiently build a particular application or a particular architectural pattern, but also how do you scale that knowledge? How do you apply those best practices across dozens of engineering teams in your organization? So that's a quite interesting challenge to tackle.
Yeah, no, sounds fascinating. You're going to get all into that very shortly, but please remember we are live. This is Office Hours. We are live, so send us your questions, send us your comments. We love a thing we always do is find out where people are from and see how sort of broad our serverless community is. So yeah, super happy to find out where you're from. Let us know in the questions and the comments. So looking back over the past week in serverless, a week ago we were talking all about Gen AI and using Bedrock and Claude. So we had a really cool demo from Santiago Flores Cantor. Yeah, just if you're looking for really good use cases for using Gen AI models and how to put them all together, really good deep dive into prompt engineering that Santi put together with lots of tips and tricks that I wasn't aware about. So yeah, super useful. And that's along with all of our other previous serverless office hours on youtube.com/serverless. So yeah, huge body of work of interesting things you can dip into. In terms of what's new, something's been coming out. Actually, EventBridge always improving the filtering capabilities. So one of the powers of EventBridge is being able to filter events so you don't pay for the events that you don't need to process, and different arrays and just a whole bunch of stuff. It's worth having a look at the what's new post to see, and I'm sure that could be useful for your applications. And then actually if you're using Kinesis, so all about high throughput streaming, this now actually supports data plane logging to CloudTrail. That does sound super interesting if it is a use case for you, but I would also think that you need to be quite cognizant of what are the costs of that going to be. You're going to be basically logging things to CloudTrail for absolutely everything that's a data plane. So all your messages are going through Kinesis. So yeah, I think super useful if that is going to be useful for you, but I wouldn't just turn it on all your Kinesis streams as a what if, just in case. In terms of blog posts, usual blog posts that are coming out recently. Nice. I know Anton's done a lot of work with Lambda extensions, and so using the circuit breaker pattern, Ian and Tobias have put together a nice, helpful blog post for that. And also Yuri Segev has done a nice blog post recently all about returning a response from a Lambda function after it's returned a response to the front end, and you can run some code in the back end to do some sort of post-return processing, which is super useful. It is AWS Summit season at the moment. I'm already looking at the list and realized I hadn't updated it with the Israel Summit, so apologies for Israelis, including Ran, who's in Israel, so I know Ran is going to be there. I must remember next week to do that. But yeah, Dubai coming up, I think, tomorrow, and we've had a whole bunch of summits recently. Los Angeles, I think, was last week. So yeah, lots of summits going on. Free, great technical content. They are huge events. lots going on. Yeah, free to attend, great AWS content. So certainly have a look at that summits page and see if there's one near you. But today we are talking all about platform engineering. Now, I come from a sort of infrastructure / engineering / platform background way before I delved into serverless. So maybe it's a silly question, but maybe we should just start with the basics. Like, what is platform engineering? Is this just a sort of new fancy name for DevOps or shift left? Why are we even thinking about platform engineering in a AWS and serverless concept?
That's a good question, Julian. That's a really good question. I really like the way you put it, right? Fancy new name for DevOps or shift left, right? Now, I think like if you look at those concepts, right? DevOps, shift left, platform engineering, they're kind of evolutions, right, of this overall approach, right, where you're trying to get to the point where your engineering teams are as efficient as possible, right? DevOps, well, I think first time I've heard about DevOps was maybe like 10 years ago, maybe a little more than that. And the idea is your developers cannot just throw their stuff over the fence, right? They need to be involved in operational part as well, right? And shift left, I think about 5-6 years ago, right? The idea is you need to empower your engineering teams, right, to do more things like, they need to be concerned with security from the get-go, with governance, right, with best practices. I think platform engineering, I wouldn't call it like it's a new name for DevOps or shift left, but it's definitely, next iteration, a next step in evolution of this process of how do you actually empower your development teams without actually putting a burden on them, right? A lot of burden. So the idea of the platform, like the name is very self-explanatory in a way, right? Devil is obviously in details, but you want to build a layer, right, that your development teams would be able to build on top of, and they are as efficient as possible, right? So if you ask me what platform engineering is, what's the point of platform engineering, is to make sure that your teams, the teams that are supposed to deliver business value, right, they don't need to be concerned with solving tasks that, like I mentioned previously, they have to solve, but they don't really want to solve. That's the idea of the platform. You're providing that layer that makes everyone building on top of extremely efficient. Right?
Okay, but then isn't AWS already sort of a platform for building serverless applications? Because obviously platform engineering comes from a very infrastructure heavy background, and there's things to do, often with a lot to do with Kubernetes and a lot of infrastructure management at scale. So what does platform engineering mean specifically for serverless? Because AWS is already a platform for building serverless apps, or not? Or yes, or both?
Well, what's the term I use mostly when I'm talking about technology, right? As a solution architect, it depends, right? So the answer to your question is obviously it depends, yes and no. AWS is a provider of the platform for building serverless applications, right? But if you remember, the shared responsibility model, right? We're commonly talking about shared responsibility model in context of security, right? So we're responsible for securing like the physical layer. In serverless applications, we're also, as AWS, we're responsible for patching the operating systems of hosts that your applications run on, your serverless applications run on, right? But it's not just security, right? It also comes to development as well, right? Yes, AWS is a platform for running serverless workloads, right? But your application is your full ownership. And inside of your application, you might have common things that need to be resolved, which are very specific to your business, to your organization. And if you let 30 different teams to address those problems, you will have 30 different solutions. This is where the platform idea for serverless comes in. AWS gives you the bottom layer of how do you actually run your serverless workloads without being concerned about servers, right? But in the serverless world, serverless platform engineering gives you additional layer. Okay, now we take all the common non-business domain specific things from your specific applications, right? And we build a platform, a serverless application platform on top of that. Ron, if you want to add something, because I think that's been your
I do. I actually have a lot of things to say, I think. First of all, let's start with the DevOps. I think that DevOps is not a position, it's a culture, it's a state of mind, and everybody should do DevOps, to be honest. Every developer Everybody should do DevOps from the development stages all the way to production, and we empower developers to own everything, the infrastructure as a code, the dashboards, observability, and they're very independent. And if it's done correctly and you're using the correct tools, they don't mind to do that. That's one thing. Now, I think that for the platform engineering, there's a short answer, there's a long answer. I think the short answer, I'm here to save the organization money. I'm here to increase the adoption of serverless because I'm a serverless platform. And I'm basically reducing the cognitive load of the developers because then they don't need to think about all the things that come with SaaS services. We are a SaaS provider. So when you build a SaaS service, a SaaS application, you need to build authentication, authorization, the login, tenant isolation, observability, CI/CD pipeline, all sorts of things that every application needs. And you got to build it at some point. So for us at the beginning, if I go like 4 or 5 years ago, we had a couple of SaaS services, and they were pretty much a tech silo. Like they were fine, but there was no unified connection between them. There were different technical stack, different observability stack. So the SREs needed to learn different tools. Developers, if we wanted at the organization level to build new services, you didn't have like a recommended golden path. And for the customers, there was no unified experience because each service was its own thing. And as their management decided to grow and build more services, we realized that we need something that unifies the experience for the developer, the SREs, and the customers, obviously. So we decided to build like this platform that everybody's going to connect and share the same services and have their their best practice of recommendations. So my job is basically to do everything in my power to make them work faster and adopt the new platform and adopt serverless as quick as possible. So that means internal SDKs, internal services, external services, blueprints, whatever I can do, advocates, best practices, whatever I can do to make it that happen. And if you want to know if it's worth it, I'll give an example that we have now an initiative that we're very close to finish that will basically take, when you start a new service, we call it service in a click. So when you want to start a new service, you're basically going to have a neat automation that will reduce the time to production. It will give you basically a hello world service that works with everything that you need. Front-end, back-end integration with the tenant management service, audit service, central pub sub, whatever, all the things that you need to be in production from our side at CyberArk, we're going to reduce the time to market by 13 weeks. That's a lot of time. So that's what we do. That's the value. So instead of everybody building the same thing over and over again, at some point we had like, I think 3 or 4 feature flags SDKs, different CI/CD pipelines, Kubernetes, containers, EC2s. Now there's a more golden path, like way for people to build new services. So I think that's my monologue for platform engineering.
Yeah, and that completely lines with my experience because, speaking to developers and, doing development stuff, there's this mythical, full platform or full stack engineer. But I mean, how big is that platform? How big is that stack? It can be infinite. And that's also crazy if you think, hang on, we need to employ full stack engineers in a company to do everything. I mean, that's absolutely crazy. In any kind of organization, you want to share best practices. You want to, have things that can be shared and reused. And these could be, logging and security and all these kind of things. Like, why wouldn't you have a platform engineering function within your company? And yeah, it'd be interesting to explore what that actually means. But why would you not have that functionality with your company to make your developers more efficient so they don't have to take on the cognitive load of learning absolutely everything and they can focus on the stuff they're good with?
Yeah, and then you have serverless. So on top of that, when I started like in the cloud, AWS cloud, we were told to build a platform and be serverless first. We had no idea. I had no idea what serverless was. I came from Kubernetes. I thought it was the best thing in the world. I didn't understand serverless. And it's funny because now I'm serverless here, like five years later, and I wouldn't go back to Kubernetes, to be honest. So we had to solve so many issues. I mean, serverless is amazing. It's an amazing technology. You can get things done very fast, but it raises all sorts of questions that you need to answer. And instead of everybody needing to answer the same questions and getting to different results, you can have like a predefined golden path. So I'm talking about how do you test serverless? How do you do observability? How do you write the CI/CD pipeline? What do you do in that CI/CD pipeline? How do you write a Lambda handler? Even this very basic thing. How do you do input validation? How do you tenant isolation? All sorts of things that we didn't know. And 5 years ago, the documentation and blogs, there were some, but not everything was covered. I mean, the state now is much better, and you have blueprints, and you have blogs, and the community is amazing now. But 5 years ago, it was much harder. So instead of having multiple teams researching the same thing, how do you do input validation in Lambda? How do you do tenant isolation? So you have a team that arrowed this research and has recommendations. That's what we do. We don't have business services. This is what we do. Best practices, serverless.
And I think I want to relate that to what we discussed about 5 minutes ago, right? It's also a platform, right? But serverless, the whole idea of serverless technologies is that you're focusing less on the infrastructure management because you have less infrastructure to management. Very rarely there is no infrastructure to management. Usually, the volume of infrastructure is significantly lower, but you have many more things that you need to manage in the application layer, right? Because now, since you don't have infrastructure, you need to build your application architectures from decoupled services, right? Serverless allows you to do that very flexibly, right? You can innovate faster, right? You can iterate faster over your microservices. But if you have 10, 15, 20 engineering teams, and they see that they need to solve exactly the same problem or very similar problems, right? What would frequently happen is that 20 teams will produce 20 solutions, right? And that's not scalable, right? That is definitely not scalable. This is something I've experienced myself in my career. When we were following this, I called it an officially Wild West approach, right? Essentially, speed is the most important thing, right? You want to go forward as fast as possible, which is totally makes sense. But then we had to do PCI and SOC 2 and HIPAA reviews. And since every single team was doing their stuff in a different way, this was unmanageable, right? It was extremely hard. So this approach of, each team is completely fully self-contained unit, right? It might work on a smaller scale. This is how many startups operate. But as your organizations grow, as the number of your engineering teams goes into double digits, right? That's where you need to make sure that you have some, I'm going to use the word that many people hate, and then I'm going to explain it, standardization, right? Some common ground, okay? Now, I think some people might have kind of raised an eyebrow when they're hearing about platform engineering because there's some, bad experience going back to how things used to work like 20 years ago with operations and development completely separated. Right, so we're still hearing echoes from these times today. With serverless, when you're building those serverless applications, you as application engineer, you want to be in control of your functions, of your queues, right, of your event bridge rules, right? Are they infrastructure? That's a really good question, right? You do manage them with infrastructure as code tools, but like event bridge rule, right, or a Lambda function or a step function, it's not a traditional infrastructure like EC2 instance, for example, right? Those are very ephemeral resources. You're only paying for them when you're actually actively using them, right? So developers want more control. And the term standardization that many years ago operations team loved implies no, developers are getting less control and we're enforcing more standardization across the board. Now, platform engineering, from my perspective, that's the approach that allows you to have the best of two worlds. The platform team will help you with the golden path, with blueprints, with templates. Essentially, this is how we do things, right? But you're flexible enough to have control over that stack as an engineering team. So from my perspective, it gives you the best of two worlds. Developers, application development team, they have full flexibility into how they build their applications, right? But the platform team actually gives them that common ground and answers the questions that every single team will be, looking for answers for otherwise on their own.
Thanks, Anton. I mean, I think there's lots we want to talk about. I do want to explore a little bit later, the whole sort of product life cycle, because, platforms and products is that sort of intersection of that. I do want to get onto that, but I know, Ran, you hinted at, what are some of the examples, and I know you have some things to show us as well, of, what are kind of the examples of things that we can do as platform engineering? And I know you've got, things that we can do in code and all those kind of things. So yeah, if you can line us up with what kind of things should a platform engineering team be thinking of taking on ownership for?
Okay, so it started in basically when we had the first, we started to write the first service, and then at some point we needed to write the second service and the third, and other teams wanted to connect to the platform. They also wanted to write a serverless service. So we realized that the best way to basically duplicate the best practices and keep the best practices and the same code, to have a blueprint. So we started to create a blueprint, which is a fancy name for a template. So we have a template repository for a serverless service, and then we had more sort of blueprints for it's basically a backend serverless service, like a API gateway, Lambda, DynamoDB, with the full CI/CD observability, all the best practices, all the things that you can think about, tests, how to write tests, how to write the Lambda handler, the hexagonal architecture, all the best practices, things that you can think of, we put into this blueprint, which basically takes you from day one. You have basically a production grade hello world service that you can extend. So this is obviously, it took us many years to extend it and iterate and add things, and we understood things better and refactored, but this is a thing that we use. So blueprint, the CI/CD pipeline. We have SDKs and libraries, whether it's for the pipeline configuration, so it's easy to, every tool that we use, it has a CLI. So if you want to run the linters, you have a cyber CLI. If you want to run the complexity checks, the unit test, deploy, everything is basically a CLI command that you can run locally and also in the CI/CD. Everything is managed by libraries, releases, and like an open source, in your open source. Then you have SDKs for the Lambda runtime, like tenant isolation, logger, metrics, feature flags, all sorts of things that we manage. And we also show how to use them inside the blueprints. Then you have internal services, like services that other teams need to connect it, like an audit service, authentication, authorization, things that you basically need in a SaaS, right? You need these kind of services. Everybody needs to connect to an authorization service. Everybody needs to send audits, which are like legally binding logs that we have. So these are services that all the services need, and basically we take ownership on that. And we also have external facing services. Like basically we have internal customers and external customers. And I think not all platforms don't usually do that. And I don't know why. It makes sense to have also the external customers. And basically think about it like you have the business services. For business services, they have a shared capability. Everybody needs to do something. And instead of having 4 services writing the same flow, like a flow that the customer triggers, instead of that, you can basically extract that code and turn it into a service that knows how to handle all the inputs and parameters of all the services. It's customer facing. So instead of the customer having to use, we call it cloud onboarding. It's an excellent service. So instead of having the customers going to 4 different UI pages in 4 different services and doing a very similar thing, and even maybe writing the same parameters to do something, they can do it in one UI screen, which is the shared platform service. And we in the backend, we send and orchestrate everything with the other services. So the customer has a better user experience, and we actually save time for the other teams to write this code and maintain it. So I think this is a very important capability that usually platform engineering for some reason don't do.
Okay, so some of it's in the blueprint where it's actually code be linters and CLI commands and input validation and all that kind of thing. And then some of it is also running on the platform, where it's a shared CI/CD platform, or login controls or auditability, or that kind of thing. Is that sort of two different ways to think about where some of the platform engineering is?
And also the services, they use our code at runtime. They use the tenant isolation SDK, the logger, feature flags, all sorts of things, service discovery services. We have all sorts of SDKs that connect with the internal platform services.
I want to relate to this, right? So, I've been doing cloud security for many years, right? And I think that this approach, right, of where you actually, instead of having a wiki page with best practices for security, you actually codify that, right? It's not a recommendation. It's actually coded in your blueprint, coded in your pipeline, right? It's there, right? It's the default implementation that is secure, not recommendations on wiki. I think this is critical, right? Especially in areas like authorization, authentication, multi-tenancy and tenancy, like data isolation. Right, imagine two approaches. One approach where, and I'm probably sound like a broken record right now, right, where every single team needs to figure out their tenancy isolation, right, and how do they make sure that data coming from tenant A is never, right, intertangled with data coming from tenant B. And the other approach is where this is functionality provided by the platform, right? So talking very hypothetically, imagine a Lambda function where tenancy is managed by one of the layers. You, as a developer of that particular application, the only thing you know that by the time you're getting control, this invocation is talking about one specific tenant that you need to care about. How exactly this is happening, handled by the logic created by the platform team. And this is just tenant isolation example, right? This can be coded into a blueprint, right? Authentication, authorization can be done the same, right? So when you're using blueprint, there's no chance that you forgot to configure, authorizer on API gateway. No, it's part of the blueprint. It's part of what you do.
Okay. Yeah, it's also just one last example. We also have CDK constructs, shared constructs that are approved by the FinOps team and the security teams. For basically, we want to have better governance to make sure that everybody's using the same tools. So we have like a S3 bucket that has the security mechanisms to block, don't be open, to the public, don't accept non-HTTPS. Maybe we have provisioned concurrency optimization, like a dynamic approach, which there was a post on my website by one of our engineers. So all sorts of options to save money and to have better security mechanism, even some patterns for SQS, dead letter queue, and redrive, things like that. So just a way to save other engineers the hassle to write this code and to save from potential security issues.
Perfect. Yeah, I know, Ran, you have some stuff to show us as well. It'd be cool to see some of this in action if you want to share your screen. And while you are teeing that up, just hello from people who have said they're talking from a number of places. In fact, it was a little bit funny. Well, Daniel is never funny, but Daniel, welcome from Brazil. And then I had hello from Peter Smith from Vancouver in Canada. And then we sort of crossed the streams where I had Nelson, a Brazilian in Vancouver, Canada. So I think we've got a bit of a Brazilian and Canadian mashup today, which is super awesome. We've done our Dirk Freuner. Hello from Germany. Dirk's been on Serverless Office Hours before, so nice to see. We've got India today, Sanket Rout, New York City. Ben, thanks for joining us via YouTube. And fellow Israelis as well, Itzik Ederi. So yeah, so cool to. And we've got Grant Doyle from Kansas. Welcome back, Grant. So yeah, we've got a nice collection. Rand, you want to share your screen and we can see, or do you want to talk about something else? I didn't want to jump in if this wasn't the right time, but
I don't know. We can talk about there's some other aspects of platform engineering.
Certainly. Happy to. I didn't want to. As you can see, we're live here, and so what you want to do, if you want to show some of the code patterns.
I'll show some code and then we can discuss. Okay, so I'm going to show you a blueprint that is basically inspired on the blueprint that we have at CyberArk. And it's an open source that I maintain, and you can use it. It has 400 something stars. I get feedback, I improve it, and I'm really passionate about it. It has all the things that we're talking about, and I'm going to show it in a second. And then after we see it, we can discuss, well, even if you have a really good blueprint, you still need to convince the people, the organization, that they want to use it, because just because it's working doesn't mean it has great user experience and people want to use it. So
yeah, no, that sounds good. So we talk about the what, because I've got loads of questions. I mean, we can talk all about, the product versus platform. How do you incentivize developers to use them? How does it not become a blocker? Whew, there's loads, but yeah, cool. We can see an example.
Right. Right. So I think we're going to start with the security mechanisms that we discussed. So this is the AWS Lambda Handler Cookbook, which I've showed last time, I think, but it has gone many changes. I've added lots of features and refactors. I had some work with Heitor Lessa from the Power Tools team. We had a reinvent session together, and we made some changes here to boost it up.
Cool.
So,
Rand, do you mind just zooming in one little notch for
yes.
people on smaller screens? That's always useful.
Right. Maybe I'll show the README just to see that people understand what we're getting here. Do you see the image here? You know what? Okay, so this is what you're getting out of the box. You have an API gateway, Lambda function, and a DynamoDB table. I think it's the best database to start with, to be honest. So it's like an order service where you can post orders. And we have also idempotency and feature flags, which are more advanced features, but I don't want to get into those parts at this moment. It's more an advanced topic, but it's here. So I think the CRUD API is basically, I think it's the good approach to start. Most services, they need CRUD API, and then they can change whatever they need in the database and then go from there. So again, it's a starting point, but usually very quickly, it looks completely different once the team starts to work. I mean, the tools, the CI/CD is still here, but the CDK code, we're using CDK, by the way, for the infrastructure as a code. But the handlers, the code, it's going to be very different, and it's okay. It's just a starting point, and then the team that works basically takes it over. So we're going to start by looking at the CDK code, and I want to show you this one. So there is a security test. So I'm using here a utility called CDK nag, which is the CDK variation of CFN. CFN lint or CFN nag, don't remember the name. What it does is basically before I even deploy the CDK code, it creates the CloudFormation template out of the entire stack here, and then it checks for security breaches or misconfigurations, which is very critical. And you can define what kind of practices you want. So here I'm using the recommended by the solution architects from AWS, but you can have all sorts of protocols like NIST or HIPAA. I don't know how to say it, like HIPAA, I don't know how to say it, but you can even build your own rules, right? So then you can have like the same rules across the organization. So basically, this will fail your pipeline if you have misconfiguration. Okay, so you can enforce correct security measures in the organization.
So this is you basically doing a CDK synth, you generating your CloudFormation template and then checking it there and then. I mean, you could do this locally, I suppose, or in your pipeline. So even before it's being deployed, you're already building your best practices in, which would be really quick rather than waiting for something to happen further along the pipe.
Exactly.
Okay, cool.
Exactly. Yeah. Yeah. And here you can have some overrides if something is not correct or whatever.
One thing I want to add here, what's important here, right? Once you get that blueprint from your platform engineering team, obviously you're going to pass all the checks, right? Because that's their job. But as a development team, you have flexibility to continue evolving that blueprint, right? You might add something that is specific to your particular business domain. And this check, it will actually make sure that whatever changes you're making, they are also compliant with those AWS solutions checks. So you're getting the baseline that is fully compliant, but once you start, if you need to evolve it, right? Once you start to making changes, it will also be validated during CI/CD process. So even your changes as a development team, as something who might not be expert in creating S3 buckets, right? Your resources will also get validated.
Yeah, and I suppose these checks aren't necessarily serverless specific. The way it's running with a CloudFormation, well, with a CDK lint or CDK nag, are these the same kind of checks you could run across EC2, run across anything at AWS? So it's not something specific for serverless, because I'm always conscious of, if we have to create a new way to do something for serverless or Lambda, it's like, I just want to use the same kind of things I'm using everywhere else for AWS. So this just taps into the richness of the ecosystem for this example, for security checks.
That's correct. I mean, it's CDK. You can if you can define it in CloudFormation, you can define it in CDK probably. So yeah. Another aspect that I'm using here for governance is the tags, which also, this is usually like an SDK, a platform SDK function. We inject the service name and the owner, like who created, and the microservice name to the stack. So to all the resources, they're going to have these tags, and it's really critical for basically understanding your resources in the console, but also for cost understanding. So the cost explorer, if you have multiple services from different teams, sometimes, I know it's not the best practice, but it happens. If you have multiple teams at the same account, these tags will allow you to filter by the tags and understand which service costs you more money and why. So it's very critical to have this. And instead of everybody remembering or forgetting to do this, you have like an SDK function for the CDK runtime, for the CDK deployment that does it for you. So again, it's the little things that go along.
So that's an interesting approach. It's a different way of taking it. Rather than telling you, oops, you haven't add tags, naughty person, add those tags into it. It's just going to add the tags automatically, and you don't even need to remember to put it in or not put it in. It's not something that's going to fail in your pipeline. It's just going to add things by default, which I like.
Yeah, I think you can also add some tests. You probably can add some rules to check if the stack tags are here or not, and then you can fail. I haven't done that, to be honest. But
this is a different approach. That's what I'm saying. These are good approaches, different ways to think about sort of enabling your bigger platform.
Yeah, but I think you should do both, to be honest. I think that I don't need to know how to use the tags, and I don't want to think about it as a developer. I just want it to work. So if I have a function that I just call and it does whatever it needs to do, great. I don't care about that. Just make it do whatever it needs to do and let me focus on writing my infrastructure. That's it.
Yeah.
I think there are two stages here, right? You have the stage where you, let's call it, enforce best practices by actually having that as part of your blueprint, right? So for example, like this, adding tags, and this removes cognitive load from developers, right? Because now they don't need to worry, what are those tags? Why, right? Why is like finance people reaching out to me saying I need to tag my 300 resources, right? So this helps you. And then you can also have, once you enforce, you can have the second part, or you actually validate for compliance, right? So this kind of gives you a complete picture. We have a guide actually on serverless land talking about implementing governance practices for serverless. So if you're listening to the session, if you're live with us, serverlessland.com has a guide for serverless governance.
I'll link that in the show notes, which will come up shortly.
Okay. So another example is we give a skeleton handler. I mean, everything here works, and when you deploy it and scaffold the template, it's going to work all the way to production. I've added support for multiple accounts, and the CI/CD pipeline will take it to production, and it will do different things at each stage. But I think it's really important to give the developers an example of what is expected of them when they write a Lambda function. How the hexagonal architecture works, where do they write everything, and how do they log, how do they write metrics. So in this example, I'm using PowerTools. For those who don't know, PowerTools is an amazing open source that basically, it's maintained by AWS. It has over 4 million downloads, I think, per month now, which is crazy. And they hold all the best practices and utilities that you basically need in any serverless application. So observability, error handling, feature flags, input validations, things like that. So here I have the entry point, my Lambda function, and I'm using the event handler resolver because I'm also using the Swagger OpenAPI generator, which is very cool by PowerTools. It generates the OpenAPI file from the code with all the schemas for the input and output. I'm using Pydantic, which is another open source library for Python for basically schema validation. And basically what I have here, I have the logger, which writes to CloudWatch logs, JSON logs. I have custom CloudWatch metrics for KPIs, because I'm basically showing these metrics in the dashboard, and I'm building the dashboard also in the CDK. So everything that you see here, it has perfect observability dashboards out of the box, and it's built in the CDK. And developers, when they see it, it should be quite easy to extend, because they see how to build the dashboard for new Lambda functions, and how to display the metrics, how to display logs. So they have examples and they have a working dashboard. So it should be easier to continue and extend it as they build their service. So here we're using the CloudWatch metrics, and I forgot to say, but here we also have the tracing, which is basically our connection here to AWS X-Ray. Again, to have performance orientation, to understand the bottlenecks in our service. Every function, I want to understand how much time it takes me. I want to have the service map in X-Ray. So all these decorators, they do that. And here I inject the correlation ID to the logger. So again, it's easier for me to debug across the services and understand the customer transaction. And here I have an open source that I wrote, by the way. It's a kind of a security approach, to be honest. It parses the environment variables to make sure that everything is there, it's configured properly, and also the values that you expect are correct. So if you have a value for a role ARN, you can specify that it needs to be in the format of a role ARN or in HTTP URL, so you can have perfect validation that your environment variables are really there before you start to use your code. And then you also have a getter to get all the environment variables, like a global getter, which is very handy instead of doing the os.getEnd, which is not very secure. So here you have the handler that calls the logic layer, and then it calls the database layer. Again, the developers, they have an example of basically how to write the perfect or correct handler, like what's the best approach that has all the best practices, the input validation, error handling. It's all here. I can go on forever, but we don't have time. But it's here. That's what it does.
Yeah, and I like the approach here that you're checking everything on init during startup. So your handler hasn't even run. If there are any kind of failures, even in your Lambda function, you have an environment variable, some input parameter that has an issue. A lot is going to be checked in the initialization phase, and then before you're messing up your business applications, if you get init failures within your function, that's also a very early warning sign that something's wrong.
So if anybody is interested, it's called AWS Lambda Env Modeler. And yeah, it's being used. I wish it's like, I think it has like 10,000 downloads per month. So people use it, and I think they should, and more should use it, to be honest. It's very small and very simple. Last thing that we can show, unless you want to talk about adoption, is the CI/CD. And the CI/CD part, I'm using here GitHub Actions, so sorry in advance. The idea here is that the developers, they get to production, they can merge their code and get the code to production from day one. And this pipeline is going to have all the best practices encapsulated, and they don't need to think about it. It just works. It's going to do everything that you need, the linters, the deployment of the Lambda functions, whatever. It's going to get you to production. You don't need to change anything. And every command that you have here, you can run it locally. So if you see, I have a makefile. So you can run it locally, because the GitHub Actions container, it does the same thing. So everything that fails there, you can run it here. There's also a make PR command that basically auto-fixes your code and runs the tests, so you can have more certainty that your code will work in the pipeline. So you have these files, and here, once the code is merged, you have this one, the main file. and it goes to the staging environment, does the deployment, does the end-to-end tests, and if that is okay, it goes all the way to production. So I'm giving here like a proper multiple accounts, multiple environments, CI/CD out of the box, and that's the idea of the blueprint, to get you to production.
I think like one of the fascinating parts that I like here is none of this is a black box for development teams, right? So like it used to be, right? There is a like different team that does all the magic, and you have no idea how this works, right? This goes back to what I said previously, right? They don't have to understand any of this, right? Because they're getting that out of the box. But do they, if they want to, right, they can. It's right there. It's just source code, right? They can go to the repo, take a look at the source code. They can make changes, right, if they need to, right? But none of that is hidden for them. So there's a lot of transparency there, right?
Yeah.
Empowering development teams, basically telling them, you don't need to worry about this, but if your use case implies you need some customization, here you go, right? None of that is a black box, right?
So it's CyberArk.
About contribution.
I agree.
Project.
Yeah, I want to emphasize that at CyberArk, every CLI command that you see here, you can basically override or change the parameters or adapt that to your scenario. For example, I have a code coverage. So usually out of the box, we expect like a 90% code coverage, which is extremely high. But if you have an ongoing service that you're going to implement this new utility of code coverage, you might find out that you have 50, 40, I don't know. Again, so we're not gonna block you from using this new utility, but we're gonna allow you to make changes to the parameters, so you can start at adding this utility, so you have visibility and gates, so your code coverage does not get any lower. So you're starting at 50%, and from there you can just go up. So you can override, change the parameters, and grow your service to the best practice as high as possible, to be honest. So everything you can override and change, and that's on you. We have the recommended settings, and if you want to change, you can. It's okay.
Cool. Do we have more code things we want to show, or
no? I think that's enough for now.
No, excellent. That's great, because I like the code sectoring approach. That's certainly part of it. But I want to sort of bring out the sort of conversation to the wider thing. And in fact, Peter Smith, thanks for joining us via YouTube, which is part of what we want to talk about next. Is how much the influence does the platform engineering team in deciding which AWS services are used in the product, or those decisions made primarily by an application teams. And the way I want to sort of think about this as well is, what is a platform? Is it a product that an internal team does? Who owns what? What do the developers take on? What do the developers not take on? Who tells who what to do? Blah, blah. There's a whole bunch of stuff in terms of getting adoption. Do developers just go, no, I don't want to use your platform, I'm going to do my own thing? Yeah. So what are thoughts on sort of actually doing this in production at scale? Where do people start? First of all, maybe let's start with what is a platform? Is it one thing? Is it a product you create? How should people think about that?
Well, so that's a good question, right? We had the discussion with Ron last week, right? And there are so many ways to kind of talk about it. So let me give you my perspective. I see platform as a layer, right? If you're taking this back to the non-serverless world, why did we need the platform? Because there was a lot of complexity to resolve, right? Complexity that is not specific to application business domain. In serverless world, that complexity, it's not in the infrastructure part anymore, because your infrastructure layer is pretty slim, right? But now you have those parts that need to be addressed across many, many different serverless microservices, right? So the idea of the platform is to go where the big challenge is and try to resolve that challenge across multiple teams. Now, what is a platform? Probably the best way to define it, right, from this perspective, is platform is a product. It's up to you to decide as organization whether it's internal product or external product, right? Usually it starts as internal product, But if you're starting this as a weekend project and you basically solving your own problem for your team and maybe one more sister team, probably it's not going to grow to become a platform, right? If you want it to be a platform, you need to address requirements of your consumers, of your customers. And your customers, in this case, that's the internal development team. So you might have knowledge, right, and expertise saying that, what, you're probably not aware yet, but this is the problem you're going to hit in 6 months. So I'm going to solve it to you for you now, right? But as a product team, you have to be what we call at AWS customer obsessed. You need to be constantly communicating with those engineering teams. You need to understand what problems they're facing right now. Like, is observability across multiple microservices a problem? Most probably it is, right? How do I standardize, right? How do I make sure it's streamlined, right? Do you need to support new services, right? So Peter, to answer your question, if there is just one team that is looking to support new service, if you ask me, Ron, you might have a different opinion. If you ask me, probably it's not yet at that time, at a phase where platform team needs to take care of that. If you're the only one who needs that new service, maybe you can implement it in your business domain and then contribute it back to platform. But if you as a platform team, you're talking to multiple engineering teams and they're saying, yep, we need this, we need this, we need this, this is where you start prioritizing this and bubbling this up and actually making it a part of your platform. So to summarize this, right, in conclusion, you have to treat platform as a product, right? Up to a level where you might have like a product manager, a technical person, usually I think as platforms are very technical things, right? Usually assigned to that. You need to have continuous feedback loop with your customers that are development teams. So you build it as a product.
So Ren, what are your thoughts on that? And also just moving it along, if you've obviously built a platform with CyberArk, how did you get people to use it? Or, what was there a carrot kind of stick kind of thing? How did that work?
Yeah, so first going back to Peter's question, the teams have complete independence. I mean, if they need to use a certain database, they can use a certain database. And then if they need like a tenant isolation there on top of that service, usually we're going to ask them, hey, let's work together. Let's figure out how we can do the tenant isolation layer above that. And then maybe you can even contribute like an open source, like code contributions to our internal SDK. And then once the code is there, we're going to manage it. So basically, they're like leading the way for this new adoption of new AWS service. And this has happened. I think the internal SDK for tenant isolation is like 50% has been donated by other services, because we're not going to use every possible service that AWS has. I mean, some services have different needs than us, which is great. But we can work together to basically make these services accessible and all the SDKs accessible on top of these new services. So I hope that answers the question. And I totally agree with Anton. It's a product. We have multiple product managers, and they discuss the requirements with both the customers, external and internal customers. We set requirements. We discuss dependencies. We discuss whether if they need something, we need to figure out, again, if this is a requirement that other people need and it makes sense in a generic purpose to build it, then there's a whole discussion whether something belongs to the platform or not. And there's all sorts of mechanisms to unblock, other teams from maybe the platform is really busy, so we want to unblock them. So you have the code contribution approach. You have sometimes starting a ad hoc squad with people from outside the platform joining the platform and working together on a new service or a new SDK and solving that. And then at some point there's a handover, and sometimes even maybe it can start altogether externally, like a business team will write something according to the best practices, and they're going to use the blueprints. We're going to work with them, make sure that everything is up to standards, and then there's a handover, and then we're going to manage that, because maybe we need to recruit more people. Maybe people are busy. So there are all sorts of ways to make sure that eventually it gets to the platform. And sometimes the service can be outside of the platform. That's also okay. I mean, if there is no capacity and the other teams, they understand that they're going to take this service and make it generic and approachable to other teams, that's also okay. It's not ideal, but things happen. I mean, you need to go on. You need to go forward.
Yeah, I think that sort of sums that up in a great way. Your platform actually should be a lightweight functionality, which is an enablement platform rather than a descriptive platform. And in fact, Dirk from AWS, who's been doing a lot of talks with Gregor Hoppe, what isn't a platform? If your users don't build anything that surprises you, chances are you didn't build a platform. And that's an interesting take, because I take that to mean that if you've built everything for users that they never need to go outside the platform, you've probably built this massive convoluted spaghetti junction ball of mud platform to do, and then you have to mandate that. But yeah, if you're, as Ran is saying, your builders are going to surprise you, they're going to come up with new use cases, new interesting kind of things. And if they can contribute to their platform as well, I think it's going to be a winner for everybody.
And I think feedback is really critical. Feedback from everybody. So when we start like a massive new service, we gather requirements, get feedback from all the personas, all the system. I send like an email to the system architects. Hey, this is the idea that we have. This is the new service that we have. We gather some requirements. Please add your requirements. Tell me if I'm doing something wrong. And many cases, I send 30 people the email and 5 chime in because it's very important to them. It's very relevant to them. And in many cases, I change the design. I edit functionality. I remove things. And then also at the implementation, once you have something working, you need people to tell you whether it's really what they expected you to build. Otherwise, they're not going to use it and you wasted your time. So feedback is really critical to understand that you're building something correct, because if you're not going to do that, they're going to build something by themselves. And then we go back to the same organizational waste that we were trying to remove in the first place. I think that's the feedback is super critical, really. Always get feedback and ask whether you're doing a good job.
Yep. We are fast running out of time. Anton, I just want to ask, because maybe you're going to do that. I just probably 30 seconds each. What mistakes do people make when you're building serverless platforms? If you can just pick one, what's something that people should avoid when they're doing it?
Ron, you want to go first?
Yes, bad user experience. Like not trying to think about. I'm sorry if I took you the item. Not thinking about the customers. Like put yourself in the customer's place. Bad user experience and not using the platform for external services. I always get questions. Oh, so you're a platform, so you're doing SDKs and infra. You're not doing anything that is customer facing. No, that's not true. I'm an architect just like you. I do everything with customers and regular. I have a product manager. So yeah, I think so.
And Anton?
Yeah, 2 very quick things. First, just to repeat, the previous question is, the mistake is you're not treating it as a product, right? You're treating it as a weekend project or something, right? You might come up with a framework that you put on internal or external GitHub, right? And it might help few people in the organization, even few teams. It's not a platform just yet, right? So it needs to be treated as a full, fledged product within your organization, right? And the second one, since it's a product, you need to prove the value of this product, right? Collect metrics, right? Talk to your users. You need to show that this product actually meaningful, because you, as a product manager, as the owner of that platform product, right? You want to evolve it further and further and further. How do you do that? You actually need to show that there is a value in what you do, right? Ron, about
there's adoption. Yeah, I think that's a really good point.
Right, I think you mentioned 13 weeks, something like that. I mean, it cannot get any better than that, right? That's an excellent metric. What's the value of that? Oh, we're saving 13 weeks per team, right? That's amazing, right?
Anton, Ran, thanks so much for joining us. We could carry on for ages. There are a couple of links that we put in the show notes, which will take you to more information. Ran's excellent Lambda cookbook with all the information over there, and also the governance page on the serverless land. Yeah, next week we're actually talking time stream databases. First time on serverless office hours. We've got Jatin and Balwant who are going to be talking about time stream databases. But for today, Anton and Ran, thanks so much for joining us. Pleasure getting all of your wisdom. Really appreciate you spending time today. And yeah, we'll